MAME is a framework that allows running software from vintage electronics in emulation on a modern computer. Originally standing for Multiple Arcade Machine Emulator and supporting video games, it now supports thousands of different machines from early microcomputers to mainframes. It's free software released under a GNU General Public License. You can install releases of MAME on a desktop or laptop computer running Linux, Windows, or Mac OS. Typically, you also need to get the ROMs or binary code for the machine you want to run the emulator for. You can get these from a real machine if you own one, or you may be able to find them on the internet. The ROMs may or may not be protected under copyright, depending on the machine and the country you live in. In this video, I'll show MAME running emulations of some computers that I own. I'm using the most recent development version of MAME as of February 2024. I'll present them in roughly the order they were introduced to the market, starting from the oldest. The KIM-1 was a small 6502-based single-board computer developed by MOS Technology, later acquired by Commodore, and launched in 1976. It featured a 6502 microprocessor running at 1 MHz, 1 kilobyte of RAM, 2 kilobytes of ROM, 6 7-segment LEDs, a 24-key calculator-type keypad, and 2 I/O ports, which supported a serial connection to a terminal or teletype and a cassette tape interface. I own a KIM-1 and have made a series of YouTube videos about it. MAME emulates the KIM-1, including the 7-segment displays and keypad. You can click on the keypad keys using a mouse or type shortcut keys on the keyboard. Like most computers of this type, the front panel interface is primitive and only allows you to display and change memory and CPU registers and to execute programs. There is support for breakpoints and single-stepping of instructions to debug programs. This is all functional in the MAME emulator. A port on a KIM-1 could be connected to a serial terminal, but this is not currently supported in the MAME version, probably because it was implemented by bit-banging the serial protocol using a parallel I/O port. There was also support for mass storage using a cassette tape. This is supported by MAME, with the program stored as audio WAV files on disk. I can demonstrate loading a small program from cassette tape, in this case a clock program for the KIM-1, which appeared in Kilobaud magazine in 1977. This is a program I had entered on my real KIM-1 and converted to a WAV file on a computer. In the MAME configuration, we associate the desired WAV file with the cassette tape interface. As on a real KIM-1, we follow these steps to load a program from tape. Make sure address 00F1 contains 0 to clear decimal mode. Enter the start address low byte in address 17F5, in this case 00. Enter the start address high byte in 17F6, in this case 02. Make sure that address 17F9 contains the 2-digit program ID for the tape. 00 means any ID. Select address 1873 to load from tape. And hit Go. The MAME key F2 will start simulated tape playback. We can hear the tape audio for a few seconds while it loads. When done, it returns to the monitor. We can start the clock program at address 0200. It then counts seconds, minutes, and hours on the display. If you set it to the correct time, it keeps quite an accurate clock. MAME also supports emulating a couple of different memory expansion cards to support more memory. Using the emulator gives you a pretty good idea of what programming an original Kim1 was like and allows you to run programs from the time. Now let's move on to some other systems. The Apple I was Apple Computer's first product, released in 1976. Relatively little known, only a couple hundred were sold, and most were returned to Apple to be exchanged for Apple II systems. Designed by Steve Wozniak, it had a 1 MHz 6502 microprocessor, up to 8K of RAM, and 256 bytes of ROM. The basic machine only provided a minimal monitor program known as WozMon. It was innovative at the time as it featured a video display and full keyboard, things which most competing systems lacked. A version of BASIC written by Woz could be loaded into RAM. It had one expansion slot, and the only official expansion card offered was a cassette tape interface. Real Apple I machines are rare and fetch hundreds of thousands of dollars when they come up for auction. I own a replica of an Apple I that was made by Retrocomputing. I've made a series of YouTube videos about it. Here's the MAME Apple I emulator. It comes up in the WozMon monitor program. Here's an example command to dump some of the memory. The original Apple I operation manual gives an example of a program to enter and run to test the machine. So let's try it. We type the start address 0, followed by a colon, and the 11 bytes that make up the program. And then start the program from address 0. When run, it should display all of the ASCII characters from 0 to 255 and repeat forever, or until we reset the machine. The MAME key F3 will reset the machine. The emulator supports the cassette interface. I have a version of the Apple I BASIC in a WAV file. Let's try loading and running it. Like a real Apple I, we need to call the read routine on the cassette interface card's ROM at address C100. We then enter the start and end addresses of the program to load separated by dots and follow them by R to indicate read. Now we can hit F2, which tells MAME to play the tape. After loading the tape, we return and can run BASIC from address E000. The greater than sign is the BASIC prompt. This version of BASIC, written by Woz, was later expanded into integer BASIC for the Apple II. We can enter and run a small BASIC program. The MAME Apple I emulator also supports emulation of a modern compact flash adapter card that's offered for the Apple I. I own one of these and have used it with my replica one. About a year later, the Apple I was replaced with the more powerful Apple II. Let's look at MAME support for the Apple II series next. The Apple II series, starting with the original Apple II introduced in 1977 to the Apple IIe sold until 1993, was one of the most popular series of home computers ever made, with an estimated 6 million sold. MAME can emulate a number of models, including the original Apple II, II Plus, IIc, IIe, and IIgs. I currently own a real Apple IIc and previously owned an Apple IIe. I'll start with the Apple IIe emulation. It supports cassette tape, floppy drives, as well as a number of other peripherals. The IIe had 8 peripheral slots. Here it is booting up with a floppy disk image of Apple's DOS 3.3 and going into AppleSoft BASIC. I can load a BASIC program from cassette tape using a WAV file I previously saved to. As I have DOS loaded, I can run DOS commands as well. Let's see the disk directory. And for drive 2, let's run a color demo program that's on the disk. Now let's run a simple game written in BASIC. Now let's look at the Apple IIc. Unlike the other Apple II series, it was a closed machine with no expansion slots, but most peripherals, including a floppy drive, were built in. Here it is booting up Apple's later disk operating system, ProDOS. Let's go to BASIC. We can switch from the default 40 to 80 column mode. And see a disk directory. MAME emulates the game I/O ports, serial ports for printer and modem, and internal and external floppy drives. We'll return to Apple computers later when we look at Macintosh emulation. Little known today, Ohio Scientific was an early leader in microcomputers, most notably for their affordable Challenger 1P and Superboard 2 computers. The Challenger 1P or C1P was a basic 6502-based microcomputer with video display, built-in keyboard, and cassette interface. It was sold as a bare board without case and power supply as the Superboard 2 for US $279 around 1980. It came with 4K of RAM and could be expanded onboard to 8K. A clone of the Superboard 2 was sold in the United Kingdom as the CompuKit UK 101. A Superboard 2 was my first computer, and I learned BASIC and 6502 machine language programming on it. I also own a Brielle Computer Superboard 3, a modern replica of the Superboard 2. A few years ago, I built a Challenger 1P replica that is identical to the original, but includes an expansion board with more memory and support for 2 floppy drives. I've covered it in a YouTube video. The C1P comes up with a prompt asking to boot from disk if present, start BASIC in warm or cold start mode, or enter the machine language monitor. Let's pick M. The monitor is very rudimentary and only supports displaying and changing the contents of one memory location at a time, loading a program from cassette tape, or running a program. Now let's reboot and go back to the monitor. Now let's select Cold Start, which enters Microsoft BASIC. And here's a sample program that displays the character set available on the C1P. MAME supports the cassette tape interface. It works much like the other computer shown earlier, so I won't demonstrate it. There's no support for any other expansion or peripheral devices. The ZX81 was a small computer introduced by Sinclair in the UK in 1981. A successor to the company's ZX80, it sold at what was considered an incredibly low price for a computer at the time, $100 as a kit or $150 assembled. The computer featured an integrated case with membrane keyboard, Z80 processor, BASIC interpreter, cassette tape interface, and TV output. The model sold in the US and Canada was branded as the Timex Sinclair 1000 and had 2K rather than 1K of RAM, selling in 1982 for US $99.95. I own a real TS1000. I've covered the restoration and operation of the unit in a couple of YouTube videos. MAME can emulate the ZX81 and the earlier ZX80. Here is the ZX81 version. Entry of basic commands and keywords used keyboard keys. You really need to see a real ZX81 keyboard in order to figure it out. Here's a simple basic program being entered. I need to enter control and shifted keys that correspond to the basic keywords on the ZX81 keyboard layout. Notice how slow it runs, as due to the hardware design, most of the time the CPU is generating the video signal. It can also run in a so-called fast mode, but the display is turned off when a program is running in this mode. Also note that the ZX81 was limited to 1K of memory, or 2K for the TS1000, so only very small basic programs were supported, unless you expanded it with an external memory expansion cartridge. The MAME emulator supports cassette tape storage, much like the other systems described here. I will show saving, as it demonstrates how MAME even emulates another odd behavior of the real ZX81. During saving to cassette, the screen shows strange random lines on the screen due to the way the hardware works. A similar screen appears when loading from tape. This is probably not a computer you would want to use for any length of time, but it is of historical interest to see what users had to go through in order to use this $100 computer. The Commodore 64, introduced in 1982, is thought to be the highest-selling single model of computer of all time, estimated at as many as 7 million units. It featured a 6502 processor and 64K of RAM with support for sound, graphics, cassette tape, and optional external floppy drives and printers. The VIC-20 was an earlier and lower-cost machine introduced in 1981 with less RAM, 5K. Back in the day, I used a VIC-20 that belonged to my father-in-law and wished I could afford a Commodore 64, which, as a student, was out of my price range. A few years back, I bought a C64 Mini, which is a half-size replica with a number of games built in, but requires an external keyboard, as the internal one is purely decorative and not functional. MAME can emulate several variants of the Commodore 64 and VIC-20. There's support for cassette tape as well as emulation of Commodore's floppy drives. First, let's fire up the VIC-20 emulator, which is not as complete as the C64 and presents a warning on power-up. Here's a sample basic program being entered and run. And now the C64 version, which is similar but features more characters per line and has more memory. Let's load a small basic program from cassette tape that I'd previously saved. It's the same example that I just showed on the VIC-20. I have MAME set up with a floppy disk image. We can see what's on the disk using Commodore's odd method of loading a basic program called $sign that has the disk directory. On this disk image is an adventure game I wrote in C using the CC65 cross-assembler and built for the Commodore 64. We can load and run it. Quite a few other peripherals are supported. See the MAME slot devices screen for details. The Apple Macintosh, first introduced in 1984, started a revolution in computing by offering the first affordable computer with a graphical user interface. By today's standards, the first Macs were quite primitive, with limited memory and processing power, a small monochrome screen, and mass storage on 400 kilobyte floppy disks. MAME supports several models of the original 68K-based Macintoshes. I own 3 models of original Macs, a Mac Classic, a Mac 512KE, and a Mac SE. All are in working order, and their restoration was covered in a YouTube video. I was able to get MAME to run with emulations of all 3 of the models, which are similar. Here is the Mac Classic booting up with a floppy image containing System 6.0.8. Here we can see the Finder version. And the control panel. And we can open up a README file and view it in the Simple Text Viewer program. The Mac emulations appear to be quite complete, and as well as 2 floppy drives, SCSI devices such as CD-ROMs and hard drives are supported. MAME was originally for arcade machines, so I thought I would try something more in that category. I own a unit of the original Nintendo Entertainment System, or NES. MAME has an emulator for it. This console ran a custom microprocessor that was compatible with the 6502 used on a lot of the machines discussed earlier in this video. The NES has no ROM on board, as all of the software is contained in the game cartridge, so you don't need to obtain any ROMs for the NES, but you do need game cartridge files. Here's an example of it running an open source game called Nova the Squirrel. Finally, let's look at something a little different. MAME has support for several pinball machines. The systems from the 1980s used similar computing hardware to early microcomputers like Motorola 6800 and 6809 microprocessors. MAME is able to run the original ROM code for some of these machines and emulate the displays, sound, and switch inputs. You can't actually simulate or see full gameplay because it doesn't model the physical elements like the balls, bumpers, flippers, etc. I actually own a couple of classic pinball machines, one of which is High Speed by Williams, released in 1986. This is supported by MAME, and I was able to run it. First, here's a few seconds of gameplay on the real machine. And for comparison, here is the MAME emulation. It runs the actual ROM code, shows the displays, plays sounds, and emulates the input switches. This system actually has 3 microprocessors, 2 Motorola 6802 and one 6809, which separately handle gameplay, the display, and generation of sounds. While not really playable, this is in line with MAME's primary purpose, which is to preserve old software and hardware and document how it functioned. I've shown here just a few of the hundreds of computers and thousands of games that MAME can emulate. Note that the emulations vary in how functional and complete they are. The MAME GUI will actually indicate the level of support for each machine. There are many more systems here I'd like to explore, and I also hope to contribute and make some enhancements. If you're interested in old computer or game platforms, I would encourage you to try it out.